Hello everyone. In this video, I'm going to give you a high level overview on what is data warehouse, what is data lake, what is lake house. So we will understand major differences between data warehouse, data lake and lakehouse, why industry is moving towards lakehouse architecture, and the list of companies, or you can say service providers, lakehouse service providers. So Databricks started this lakehouse architecture, lakehouse services in 2020 with the Delta integration. Now Synapse Analytics also providing with the Lakehouse architecture, that is Azure Fabric with the ADF integration, data science, data machine learning, and data engineering. The Synapse one, so everything they are integrating to support a Lakehouse architecture. So before moving to Lakehouse, first we need to understand what is exactly data warehouse, what is data lake, the major advantages from data warehouse, major advantages from data lake, then combining together. So lakehouse is a combination of data warehouse features, then data lake features. That is lakehouse. But first we should have idea what is exactly database, different types of databases. So when it comes to SQL databases, RDBMS for OLTP transaction purpose, like ERP, Enterprise Resource Planning application purpose, you can find IBM DB2, Oracle database, SAP HANA, MySQL, PostgreSQL, Sybase. These are transaction OLTP databases, OLTP application purpose backend databases. Similarly, data warehouses also is available. Like these databases are providing OLAP also. Then some databases are available at cloud, MPP data warehouses. These are on-premises MPP data warehouses, cloud-based MPP data warehouses. Like Teradata is providing MPP data warehouse. Vertica is an open source. Netija from IBM, MPP data warehouse. Hive from HDFS, open source distributed file system. Then when it comes to cloud, Amazon is having a Redshift, Google is having a BigQuery, Microsoft is having Azure SQL data warehouse, Snowflake. These are MPP data warehouses. MPP data warehouses. Even traditional data warehouses are available, MPP data warehouses are available, even that MPP data warehouses are available in cloud as well. Okay. Even there are some databases are available, NoSQL databases. So NoSQL, when we look at a high level document store databases, key value pair databases, wide column store databases, graph store databases. There are plenty of databases are available. These are NoSQL databases. So databases means where we can store information, but primarily databases like transaction, OLTP, OLAP, MPP data warehouses. Other than NoSQL, MPP data warehouses, OLTP data warehouses, OLTP databases, OLAP databases, OLTP and OLAP. So these databases are MPP databases. They'll allow structured data. They can store structured data. That we will understand now. So before that, just I need to give some other information other than this. High level, at least when we compare with the data warehouse and when we compare with the data lake, when we compare with data lake and data warehouse, at least high level, any database, maybe OLTP database or OLAP database means data warehouse. Maybe OLTP database, online transaction purpose or processing database, or OLAP database. So any RDBMS if you take, they'll have inbuilt storage, inbuilt processing engine. Means they'll be having a metadata, database files, and a separate, that is database storage. So whenever you read data, the queries is going to submit on server or instance SQL server, Oracle server, or particular database server. It's an in-memory based processing engine. In-memory based processing engine, that is a server or process. So, but both are inbuilt storage, inbuilt compute. So these are 19 70s, 1980s databases, 1980s databases. Okay, so that time 1970 and 1980s compute power. When we talk about compute power, mainly disk, disk, traditional hard disk, then network. So that time network bandwidth, disk bandwidth is very low, very low. So if they store data separate, if they have a separate processing engine, the data should process over the network, plus the data should store in a different servers. So network bandwidth will be very less in those days. Network bandwidth will be very less in those days. Then disk throughput means the disk when you are reading data from disk, writing into disk, these data. So if they have a separate storage, separate processing engine, it will impact for performance because of low bandwidth network, low bandwidth disk, old disk. Nowadays we see GBs, terabytes of network speed plus SSDs, solid state drive. So nowadays the compute power is improved a lot. But those days they can't split store data separate and processing engine separate because of less bandwidth network and low disk IO. So number of files per second we can read per second, write per second is very less in those hard disks. That's why traditional databases they build inbuilt storage, inbuilt processing engine. Any database, maybe Oracle, DB2, SQL Server, MySQL, their concept is inbuilt storage, inbuilt processing engine. Inbuilt storage, inbuilt processing engine. Without this server, you can't. So without that SQL instance or SQL Server process, you can't read this data. The server should be always available. So that is inbuilt storage, inbuilt processing engine, compute power. So they are not separate. They're not separate. Then when it comes to nowadays data lake, when it comes to big data is having a two parts, separate storage. When we talk about a databases, the storage is inbuilt, right? But big data, the storage is separate. So that is data lake. It can store data separate, which you can use any compute power like this SQL server. We can use a Spark, Hadoop MapReduce, or any other tools to read data from this data lake. So data lake accept any type of data. Data lakes are distributed. Data lakes are distributed, which it will split and store on multiple nodes, which we can see the last 10 years the compute power, SSDs and network bandwidth is increased a lot. So you don't see much performance issues. Okay, and it will support native file formats. So that's about data lake. Even lot of things are there. We'll continue. Again, first we'll understand data warehouse part, then we'll continue on separate storage, separate compute part. But databases are inbuilt storage, inbuilt compute power. So without this server, if the database instance or server is down, this is purely in-memory based, then you cannot read data from disk. So it's an inbuilt storage, inbuilt compute. Then when it comes to OLTP databases, wherever application is there, backend database will be there. Whenever you do transactions, maybe Facebook, whenever you log in a Facebook account, or whenever you do any transactions on like e-commerce applications or banking applications like Flipkart, Amazon, or any banking account. So online banking or any supermarket, whenever you visit, right? So they'll have some enterprise resource planning application. So there they'll enter the data, maybe through online application or maybe offline application. The backend, they'll have a database. The database majorly online transaction processing database type to process critical data, and the latest data will be there, and mainly structured data. Only few records will get updated. Okay, so ACID properties will be enabled. So isolation, recovery, and integrity are critical in that transaction database application, transaction databases. So when it comes to OLTP databases, so this database will have a historical data, mainly we will use for analysis purpose. So different sources data, a decision support database that is maintained separately from the organization operational database. Operational database means OLTP, transaction database. OLAP means data warehouse. OLAP means data warehouse. A data warehouse is subject oriented, integrated, non-volatile, and time variant data. So collection of different subjects data. So mainly we'll use for decision making. Means organization they'll use for analysis purpose. Both are databases only, but the purpose, one is for analytics purpose, OLAP, that we will call it as data warehouse. One is for transaction purpose, OLTP, that mainly application backend databases, to support the transactions, But these databases, when we look at these databases, okay. So traditional data warehouse projects, sources, maybe any ERP applications, backend they'll have a OLTP databases. And the target is data warehouse. Data warehouse is nothing but OLAP data warehouse. OLAP. So this is 1980s traditional data warehouse projects. Different sources data will integrate into warehouse, different sources data using any ETL tool, and that data will use for analytics. So those warehouses may be any of these databases. The database type is warehouse. Warehouse is nothing but OLTP type. Sources will be OLTP, any applications data, any front-end application. Back-end they'll have a databases. But when we look at these databases majorly, okay, so the database will have a historical data, mainly single source of truth. That entire organization data they'll be having in one place. That entire companies, you can say central data store, single source of truth. Then mainly they'll use for business analytics, analyzing the existing business data, or launching new business models based on existing data, and enhance customer service and interaction, boost quality and resource utilization. But what are the missing things in this data warehouse? So they'll support only structured data. If you have a data like a video, audio, text, semi-structured, unstructured data, we can't store here. And these data warehouses will have a limitation. They'll support only traditional BI, not for advanced analytics like data science and machine learning. So, but majority of the companies nowadays looking for advanced analytics. They're looking for data science. They're looking for machine learning. They're looking for advanced analytics combination, deep learning, machine learning, data science combination. So that is not possible with the traditional data warehouse. Okay, so data warehouse is having some advantages. Structured data, transaction purpose, it will give you better performance when you are reading data. It will have SQL language support, cost-based optimizer will be there. That's about the data warehouse. But data warehouse also having some disadvantages. So that we are expecting in some disadvantages which we can overcome using data lake. Then what is data lake? A data lake is nothing but distributed file system. It's maybe Google is having a distributed file system, HDFS Hadoop distributed file system, or Amazon is having their own S3 distributed file system. Azure is having a distributed file system, IBM, Oracle. So nothing but a data lake. A data lake can store any type of data, any size of data. Means structured, semi-structured, unstructured. Any size, n number of files, n number of folders. So files and folders which you can store. It's a file system, data distributed file system. Okay. So that may be any big data processing purpose, which you can store data and which you can use for big data processing, or IoT, or any other analytics, on-premises data migration, or any traditional reporting, or advanced analytics. Data lake we can use for multiple use cases: advanced analytics, traditional analytics, on-premises to cloud data migration, big data processing, or IoT or machine learning purpose. Same data lake you can use for multiple use cases. Okay, but when you look at these companies are providing data lakes. Okay, but end-to-end project, when we look at analytics project, right? So analytics means maybe advanced analytics, maybe traditional analytics. But if you are storing any type of data and data lake, structured, semi-structured, unstructured, but traditional BI they can't use because these data lakes will have files and folders. So what we will do, we will store all type of data in data lake. Then we'll have a separate data warehouses in cloud when we look at the cloud. Maybe Amazon Redshift, Hive, BigQuery, Azure Data Warehouse, or Snowflake. So we will use again this additional process, we'll convert into structured format, we'll store into these data warehouses, then that data warehouse is dimension data model and reporting purpose. Problem is, the major problem with this architecture is separate data lake, separate data warehouse. So you are managing data lake to store all type of data. So data science team, machine learning team, they can use that. Plus you are managing separate data warehouses. So data lakes plus data warehouses. It will increase the project development cost because you are doing additional activity load data into data warehouses, managing data in data lake. Then that processing cost or storage cost, everything which we need to include in the project cost. So why can't we avoid these data warehouses? Why can't we directly use these data lake, and why can't we directly read data from the data lake for analytics use cases? Analytics use cases. So data lake is having some disadvantages. So those all are advantages. Means every data lake you can see, maybe Azure, maybe Google, maybe AWS, they are cheaper. First one is cheapest storage cost. You can store any size of data, any type of data, structured, semi-structured, unstructured, and any variety, any size. Then ingest in speed, native format which you can store. While reading, you can read schema and read. Okay. Then cost saving. So if you have a huge data on premises, that you can go with different types of storages, hot, cold, archive storages. Then the same data lake you can use for other analytics use cases as well, like IoT, okay, streaming and other purpose as well. And great accessibility. So data lakes can be accessed globally, depends on the service provider. Okay, advanced algorithms. So security point of view also, for analytics point of view also, which you can implement on top of the data lake. But the major disadvantages when you look at a data lake, missing database features. So incremental load is very time consuming and a critical task which you need to implement using programming languages. Then it is tough to modify existing data. Like databases will have a update, merge, these kind of operations. That is data manipulation language, DML. But data lake is a file system. Only you can achieve append or overwrite. Append or overwrite. If any data, any job is failed, it will have a corrupted data files as well. So you need to identify and need to remove those missing files or corrupted files. Then data governance, too many small files issue, too many small files issue. If you have more number of files, when you're reading data, it will take more time for opening and closing files rather than reading data. Data quality, don't expect data quality because there is no constraints concept, there is no metadata concept. Because once we store data in data lake, while reading, we will specify the schema, not schema on write. So schema on write is missing. So because of that, you can't expect data quality. Plus ACID transactions are missing. ACID properties are missing, which you can't do update, delete, insert, multiple operations. You can't do that. So these are database features which we are expecting on top of data lake. So that is possible in Lakehouse. What exactly this Lakehouse? What data will be there in data lake? Backend storage is going to store on data lake, structured, semi-structured, unstructured. But on top of that, we will use API. That API is called Delta Lake. So Delta Lake is going to enable all data warehouse features. So your data lake features plus your database features will be available. So you don't need to use separate data warehouses, which we can use for real-time analytics, traditional BI, data science, machine learning. So Delta is going to support all these use cases. The backend data is going to store on data lake only, but the Delta will enable whatever features we are expecting from data warehouse features. The data warehouse features is going to provided by this Delta Lake. Similarly, other competitors also available. Okay, so like Delta is also open source, Iceberg is available, hudi also is available. So when we look at other cloud service providers, Delta also we can use. Data is going to store in any data lake, but Delta is going to enable data warehouse features on top of data lake, that is Lakehouse, or maybe hudi, or maybe Iceberg. All are open source file formats, which it will give you data warehouse features, nothing but database features on top of data lake, So what you will get? You will get ACID compilant, or you can say ACID properties enabled on top of data lake, which time travel also, version controlling, nothing but time travel snapshots, audit log. So all your database features which will be enabled on top of data lake. So you will have a data warehouse features, data lake features. And you can use for real-time analytics, you can use for machine learning, you can use for data science, you can use for BI. Multiple use cases. You can use for real-time analytics, streaming analytics, traditional BI, data science, machine learning. But data always is going to store in data lake. On top of the data lake, the Delta will enable you. Then what are the skill sets required to utilize this lakehouse? It's not only for Databricks, any cloud. If you are looking for lakehouse architecture, Delta is a common API. Languages, PySpark and SQL. Spark SQL, PySpark. So Spark, PySpark, Spark SQL, Delta Lake. These are key skill set, maybe in Databricks, maybe in Synapse Analytics, maybe in Azure Fabric or any other Google Cloud or AWS Cloud. Wherever Lakehouse architecture is there, these all are common skill set to give you or to enable Lakehouse architecture to get benefits of modern analytics, the combination of real-time analytics, traditional BI, data science, and machine learning. So this is about a complete high-level overview on data warehouse, data lake, lakehouse. What is data warehouse? What is data lake? What is lakehouse? So lakehouse is initially introduced by Databricks. Now Synapse also available. Recently again Azure Fabric also is providing a lakehouse architecture. Other cloud service providers also is providing that. Data warehouse features plus data lake features is nothing but lakehouse architecture. So this is about data warehouse, data lake, lakehouse. If you're not subscribed, please subscribe my channel. See you in another video. Have a good day. Thank you.